Hi, and welcome to 5-Minute Chemistry with Always Eclectic Stacy. This is the covalent bond series, and this is the second example of how VSEPR and Lewis structures can work together to model the molecular geometry of a molecule. Let's go. Hi, and welcome to 5-Minute Chemistry. Today we're doing another example of the VSEPR model with Lewis structures, where we're talking about how we take a molecular formula, change it into a Lewis structure, and determine the polarity and the molecular geometry. So the one we're going to do today is H₃O. And before we move on, we're going to go ahead and name it. So there's two potential names. You have the common name, which is water. And you have the proper chemical name, which is dihydrogen monoxide. Now, two things to remember with H₃O is the first thing we're going to do is go ahead and draw those Lewis structures, Lewis dots, and remember oxygen has 6 valence electrons, so it has the 6 dots, and hydrogen has 1, so it only has 1 dot. The big important thing to remember is that when you're dealing with hydrogen or anything from the halogen family, they're always terminal because they really can only make 1 bond each. So we're going to go ahead and start making our Lewis structure. And we're going to go ahead and put oxygen in the middle. And, oh, I'm so sorry. Let's do the polarity first. So oxygen has a electronegativity of 3.5. And always put the higher electronegativity on top. And hydrogen has an electronegativity of 2.1. And that leaves us with a 1.4 difference, which makes this very polar. Now remember, when you're dealing with polarity, it's often going to be at an angle. So we're going to go ahead and put that oxygen in at the very top of our Lewis structure. Sorry, it's kind of wandering from me today. And we're going to go ahead and put in those downward lines for our H's. And we're going to go ahead and put in our final dots for oxygen. And we're going to go ahead and count our things. So 2 lines equals 2 bonding pairs off of the central atom, which is oxygen. So we have 2 bonding pairs. We also have 2 lone pairs. So when we look up our molecular geometry for 2 bonding pairs and 2 lone pairs, we're going to go ahead and realize that this is trigonal planar. Before I end the video, I want to remind you that we really should, best practices, go ahead and put in those poles. So because oxygen is a higher electronegativity than hydrogen, it's going to be the negative pole. So you kind of go ahead and put in this little symbol with a positive. Sorry, that should be negative. I was thinking I was on hydrogen. Sorry, guys. Here's hydrogen with a negative. I know it's supposed to be an F. I'm S. I'm not the best at making these symbols. Thank you again for watching 5-Minute Chemistry with Always Eclectic Stacy. And if you like these videos, please do not forget to like and subscribe. Have a great day.